Okay, good morning, everyone.
Good morning.
So, today we'll start with our main objective of this module, which is calculus. Our objective was to understand how to find out the double and the triple integrals. The basic part we have already covered. So, now just the prerequisites are like some generalized UV rule, which will be this is a very important rule actually. And in your 12th standard, you did the integration u into v dx. What was the formula? UV rule.
Sir, it was a u integral v dx minus integral uh, v u dx. So v dx
V dx.
v dx minus integral du by dx whole dx.
Hmm. Anyone else?
V into u dx upon uv.
What you said? Can you repeat it?
Yes, sir.
No, no, not you. The other one.
Sir, v dx v u dx upon uv.
No.
du by dx integration v dx whole dx
Du by
dx
d. Yes. Integration v dx whole dx. So this was u integration of v. I mean, in short or roughly, I can write like this: u integration of v minus integration u dash integration of v. Okay, this kind of UV rule you have seen in the previous classes. And what is generalized one now? Okay, so generalized UV rule says that I can apply this U into V rule 2 times, 3 times. In many of the examples, you have seen it like this. So you have x square sine x dx. Okay, so what we have to do in this kind of cases is I have to apply this UV rule twice on this. UV rule is applied twice. Applied twice. Okay. If it is cube, then I will have to apply it thrice. Okay, so to I mean shorten my efforts, what we are going to do is we are going to generalize this rule. And how do I generalize this? Just apply the UV rule here. So u, when I take the integration, suffix represent integration. Represent integrations, and power represents derivative. Okay, remember this. So u integration of v. So v1 I will write it down here as this is the integration of v minus integration what we have, derivative of u. The power represents the derivative. So u1 integration of v, that is v1 dx. I hope it is clear up to this. Now apply UV rule on this again. So u v1 minus. When I apply the UV rule here, u dash as it is, integration of v1, what I should write down? There will be integration of v1 dx minus integration, take the derivative of this term, that will become u double dash integration of v1 and total dx. So I am asking you what I should write down here. What suffix represents
maybe
number of v? V2 minus integration. You have u double dash and this will become v2 dx. Right? So if I open the bracket, u v1 minus u dash v2 plus integration u double dash v2 dx. Now again I can apply UV rule to this. So this will become u v1 minus u dash v2 u1 actually plus in bracket u double dash as it is integration of v2 dx minus integration, take one more derivative of u, I'll write down 3 and integration of v2 total dx. Can you simplify this? u v1 minus u1 v2 plus u2 into
V3.
V3.
v3 minus integration u3 v3 dx. So I can do it in the same manner. What will be the final formula if I go on doing this? U v1 minus u1 v2 plus u2 v3 minus u3 v4 plus and so on. So we are not doing anything new here. We are just generalizing. I mean, whenever I come to some example where I will have to apply the UV rule twice or thrice, I will directly use this formula. So generalized UV rule, very important. UV dx is equal to U V1 minus U1 V2 plus U double dash V3 and so on. Suffix represent number of derivatives. If you have read R.D. Sharma, then you can probably tell me this. e to the power ax upon e square plus b square in bracket a cos dx plus b sine bx. Standard formula. Integration e to the power ax sine of bx dx equal to, don't know,
E to the power ax upon a square plus b square.
ax upon a square plus b square
A sine bx minus b cos bx plus c.
minus b cos bx. Exactly. The plus c part is there, of course. Fine. There are a lot of other tools also, but I'm not going to introduce you to the other tools of integration, gamma, beta, reduction, formulas. I'll try to keep it simple, as I said. Now, when you do the definite integral, say integration a to b f of x dx. What you're doing, we are having this lines, x axis, y axis. You have the function y is equal to f of x. When you do the integration from a to b, a and b are the points on x axis. And integration a to b f of x dx represents this area under this curve, right? But what is the crux? What I want to tell you is that you are integrating f of x over an integral. So we are integrating f of x over an interval. Very important point. Why it is an interval? Because there is just one variable x. In the first lecture, when we started with calculus, I introduced you to the functions of more than one variable. So consider u equal to f of xy. In this case, your domain for this function f of x. What do you mean by domain? Anyone? What do you mean by domain?
A set of all values that the function can take.
Set of all the values that a function can take. I mean, we can also define it in this manner that whatever independent variables you have, uh, the values of those independent variables from the space that I'm taking. In this case, I have two independent variables x and y. Okay. So if I want to graph this kind of function u is equal to f of xy, what will happen is my input is going to be from the xy plane, right? My input is going to be from the xy plane, and I'll get the some point on this, and I can integrate over some part on the xy plane. I hope you are getting this. So my domain, when I have function of two variables, will be from the xy plane. So I will integrate over a region in xy plane. So consider u is equal to f of xy. Then the double integral, I'll rub this part as consider u is equal to f of xy. Then the double integral f of x comma y dx dy is calculated over an interval, over an interval. No, sorry, over an area in xy plane. Okay. So can you tell me now if u is equal to f of xyz is a function, then so the triple integral f of x y z dx dy dz is calculated over calculated over have you understood why we are taking an area in this case? The two variables you have independent one, x and y, they comprise of a region in xy plane. So over that region, I can evaluate it. So triple integral will be done over an
area in XYZ plane.
can we say area in xyz plane or xyz
Parabola.
comprise three-dimensional space? It is not a plane, right? So it is
Yeah.
calculated over a volume
Volume.
in xyz space. Okay. The next thing is why there are this dx, dy, dz. When you talk about this integration y is equal to f of x, if you remember, if you are integrating from a to b, this is y is equal to f of x. What you were doing was you are making small rectangles in this, right? And a complete proof was also given to you. So if you have the interval a to b, then you divide this into n equal parts by b minus a divided by n, right? So what we will get x naught equal to a, x1, x2, and so on up to xn equal to b, right? Now, what we were doing was we were considering this area. What will be the area of the first rectangle? That will be this value, the lower one. F of x naught will be the height of that rectangle. And what is the base? B minus a divided by n. The similar one will be f of x1 into b minus a divided by n, and so on. This will go up to f of xn. b minus a divided by n. Right? So this was called as some h as the or n. And then what we did was we took the limit n tends to infinity for this. When we take the limit n tends to infinity, we get the integration. That was the complete idea. So this term, this small length on the x-axis was dx, right? So in two-dimensional space, it is on corresponding to x-axis, dx is there, corresponding to y-axis, dy is there. When we go to three integrations, we have dx, dy, and dz. Fine. So when we are solving the double and triple integral, it is again same like our partial derivatives. So partial derivatives said that when I'm integrating with respect to x, you treat the variable y as constant. When I'm taking partial derivative with respect to y, you treat x as constant. And in the similar manner, we take the integration. Okay. So I'll solve one or two examples and then you'll be able to understand what I am saying. So if I want to evaluate integration 0 to 1, don't think about the limits, how the limits are done. We are going to discuss it after some time. So we have x square plus 3y dy dx. In this case, order is very important. So if I want to evaluate this, how I'm going to do it? Integration 0 to 1 in the bracket, integration 0 to x square plus 3y. What is written first? Dy, then dx. Integration with respect to y. Integrating with respect to y, x will become constant. What will be the integration? Integration of constant with respect to dy. I mean with
X
respect
cube
to
y. X square
x,
y.
x square y plus 3 is a constant. Integration of y with respect to y.
Y square by 2.
Y square by 2. Limits are 0 to x dx. So this is integration 0 to 1. Put the upper limit, but upper limit should be given to y because you have done the integration with respect to y. So that will be x cube plus 3x square divided by 2. This will be for the upper limit. If you put the lower limit, both the things are 0. Or this will be now integrate with respect to x. That will be x raised to 4 divided by 4 plus x cube divided by 2. Please check the calculations. Limits from 0 to 1. So this is 1 by 4 plus 1 by 2, which is equal to
Sir, can you scroll a bit up? More. Yes, sir, done.
integration 0 to 1, 0 to 1 minus x plus y dy dx. Order is important. I am telling you, you cannot interchange dy and dx here. 0 to 1 in bracket integration 0 to 1 minus x plus y dy dx. 0 to 1. Integrate with respect to y. The first one will be
xy
xy
plus y square by 2.
y square by 2. 0 to 1 minus x dx. Then integration 0 to 1. Put the limits. These are the limits for y. So that will be x into 1 minus x plus 1 minus x square divided by 2. This is dx. Let's open the bracket. 0 to 1 x minus x square plus
1 minus 2x. So we can solve the bracket.
if we solve it, then it will become difficult to integrate.
Okay.
So integration of x square by 2 minus x cube by 3 plus 1 by 2. Integration of 1 minus x square. That is simply 1 minus x raised to 3 divided by minus 3. I hope it is clear why I took minus 3 there. X raised to n plus 1 upon n plus 1 and coefficient of x is minus 1. That's why this minus sign is there. Put the upper limit. We can see that if we put the lower limit, there is a non-zero term. Okay, anyways. So 1 by 2 minus 1 by 3 minus 1 by 6. Upper limit minus. Put the lower limit. First term is 0, second term is 0, third one will be minus 1 by 6. So the answer is
1 by 6.
1 by 6. Third one, I want you to solve it. Integration 0 to 1. Integration 0 to 1 dx dy upon under root 1 minus x square under root 1 minus y square. So integration 0 to 1. The first integration is with respect to x. Remember that. So integration 0 to 1 dx upon the root 1 minus x square. This root 1 minus y square is a constant when you integrate with respect to x. So I can take it outside the integration 1 minus y square dy. What is the integration? Integration of 1 upon root 1 minus x square.
Sin inverse x.
Sin inverse x.
Inverse x.
Sin inverse x. From 0 to 1 dy. Sin inverse 1, which is pi by 2. Pi by 2 will come outside. Again, integration of 1 upon root 1 minus y square, that will be sin inverse of y. Limits from 0 to 1. So the answer is pi square divided by 4. So evaluating part is clear now. So once we are done with evaluating part, we'll look how do we get the limits. Okay, how do you give the limits to this kind of integrals? So for that purpose, the fourth example I'm going to write down, which you can solve later and find out what is the answer for this. So integration 0 to 1. Other integration is x square 2 minus y dy dx. Can solve it later. I will go to the limits part just to make you help you understand how we are doing this. So what I have, I is equal to integration 2 minus x. This is sorry. Whom you are integrating with respect to first? First you are integrating with respect to y. These limits are going to be for y. These limits are with respect to, these limits are for which variable?
X.
X. Okay. So this is the structure. I will write down this now. X is equal to 0, 2. X is equal to 1. Y is equal to x square 2. Y is equal to 2 minus x. Y is equal to 2x. 2 minus x is nothing but x plus y is equal to 2. Let's draw the diagram for this now. What are the equation y equal to x square? This is a parabola opening towards which axis?
Positive
Y
x-axis.
positive
Positive y axis.
positive y axis. Whichever variable has power 1, towards that variable the parabola opens. Y is having power 1, so it is opening towards the positive axis. The other one, x plus y equal to 2. This is a what is this? X plus y equal to 2.
Straight line.
Straight line. If I want to draw this straight line, I will have to take 2 points. The first one is the x-intercept. X-intercept is 2, 0. y-intercept for this line is 0,
0,
2.
2.
Draw the line. Okay, y equal to x square is this. I want to identify the region. We have seen that double integration is always done over a region in xy plane. I want to identify the region. What is this point of intersection? How do we find the point of intersection of parabola and a line? Put one equation in other and solve. And if you're smart enough, just by looking at the equations or looking at the curves, you can tell me this point.
1,
1, 1.
Will be 1.
Right? So my x is going from 0 to 1. Where is x? 0 here. X is growing from this point to this point. Your y is going from, what are the limits for y? It is going from this. What is this? This is parabola. और upper limit क्या है y की? Y is going up to the line. So which region it can be? Sum up everything. X is going from 0 to 1. The parabola, the limits of y are from the parabola to the line. So which region this can be?
The triangle in the middle.
The triangle in the middle. So this is the part over which you are integrating, and how we identified it. Okay, we have identified it by the limits. Okay, this is the region over which you are integrating. In this region, you can see that x is running from 0 to 1 and y is going from the parabola to the line. Okay, so this is how how we have identified it. But there should be a way by which I can give the limits, right? So in the previous example, if you see, there was dx dy. In this case, you have dy dx. Okay, so I should be able to give the limits if I want to understand how it is. The proper way of giving the limits. So for that purpose, let's again write an example where we have to find out the limits for a particular integration. So double integral over r x square plus y square dx dy over the area bounded by. the triangle whose vertices are 0, 1, 1, 1 and 1, 2. Okay. Zero, 1. So this point A, 0, 1. 1, 1 will be here. Point B, 1, 1. X coordinate 1, Y coordinate 2. C, 1, 2. This is my region and I want to give the limits. What can you tell me about X? X is going from
0 to
0
1.
to 1.
0 to X equal to 1. Y is going from
1 to 2.
So if you draw the diagram for this, whatever you are saying, X equal to 0 to X equal to 1. It will give me this complete area between these two lines. Y equal to 1, Y equal to 1 and Y equal to 2. What is the combination of these two? It is this rectangle. Sorry, that will be a square. But is it a square? Is the value of Y constant? The upper limit is constant for your region. Is the upper limit constant? Is the upper limit constant? Is it simply 2 throughout your region? This is your region. In this region, is the value of Y 2 always? Upper limit is 2.
No.
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 So the upper limit is up to this line. Can I say that? The upper limit is always a line for this. Okay. Or the equation of line, if I have to write it down, then y is equal to x plus 1. Okay, this is the equation of line. So y is running from 1 to y is equal to x plus 1. Okay. Now we have done this roughly. I don't have a standard procedure, so I will define a standard procedure now. So whenever we have a region, once we have drawn the region, what I will do is take a strip. Take a strip parallel to y-axis. Take a strip parallel to y-axis. When you take a strip parallel to y-axis, you need to define the range over which you can move this in your region. So I can move this strip horizontally from x is equal to 0 to x equal to 1. Okay. So when you take a vertical strip, first of all, you define the region over which you can move it. So I can move it from x equal to 0 to x equal to 1. So x is equal to 0 to x equal to 1. Then you give the lower limit of your strip to the upper limit of your strip. So you have drawn this vertical strip. What is the lower limit of your this strip? It is this line. The equation of this line is y equal to 1, 2. What is the upper limit of your strip? It is a line. On this line, the value of y is y equal to x plus 1. So if I want to evaluate this, what I will do is x is equal to 0 to x equal to 1. Y is running from 1 to x plus 1, x square plus y square dx dy. Can I take horizontal strip? Take a strip or take a strip parallel to x-axis. Okay, so let me just copy the diagram here. Now what I'm saying is take the horizontal strip. What is the range over which I can move this horizontal strip now? In your region, how can you move this? Now it will move vertically, right? So what is the range?
0 to
For x or y? No, when the strip was vertical, you moved it horizontally to cover your region. Now it is horizontal. How can you move the strip now? It will move vertically. From where to where?
y equals 1 to 2.
Y is equal to 1 to y equal to 2. Exactly. Parallel to x-axis. So we'll have y is equal to 1 to y equal to 2. What is the left hand side limit of your strip? Left hand side of your strip now? It is the line. What is the equation of the line here? X plus y, sorry, y is equal to x plus 1. You have given the limits for y, right? Now give the limits for x. देखो, whenever you want to measure horizontal, you go for x-axis. When you want to measure for vertical, you think of y-axis. What is the value of x on the line? That is
Y minus 1.
y minus 1. 2. Upper limit for x,
1.
1.
1. Okay. So, as we discussed, there is nothing particular about taking the strip horizontal or vertical. Accordingly, we will manage it. Y minus 1 to 1. X square plus y square. What I should write first?
Dx.
Dx and then dy. So both the ways we can do. We'll solve some more examples in the next lecture where the limits are not provided. We will give the limits and we'll solve the example. I'll conclude the lecture by taking this remarks. I hope there is no difficulty in this.
So can you show that example once again? This one.
Which one? This one.
Yeah.
Everyone think if there is any difficulty, because if there is not, then I'm going to ask you one question. You should be able to answer it.
So in the previous one also.
Sir, can you show the question? Yeah, this one. Yes, sir, done.
No question at all.
Sir, for after that, or can you tell the how x came, means x is equal to y minus 1 to x is equal to 1? I got disconnected.
It is from this line to the vertical line. On this line, the equation is y is equal to x plus 1. So the value of x will be y minus 1.
Yeah, that then x is equal to 1.
This is the vertical line. For the vertical line, the value of x is 1.
Okay.
Okay. My question is now, why not x is equal to 1 to x is equal to y minus 1? By the time I will write down the remark, you think over it. So the if strip is taken parallel, if the strip is parallel to y axis, then x and limits of x are constant and limits of y depends on x. Second, if the strip is parallel to x axis, then limits of y are constant and limits of x depends on y. Fine. Anyone who can give this answer? You said that we understood it. We are very much clear. Now tell me.
Sir, it's because of the limits that we are going from x is equal to y minus 1 to x is equal to 1, but the other one can, it cannot be the other way around because the function is only given like that, means you need to take the limits from that.
No, no. Yes, Manas.
Um, maybe it's because the horizontal line is moving vertically and its right end is fixed and its left end is moving from.
Mm.
Mhm, mhm. No.
Yes, Shivani.
So
Shubham Kulkarni.
Sir, I'm thinking.
Eh, there is Sakshi.
So I don't know about it.
Chris. Aditya. Tell me.
Sir, maybe because x equal to 0 is the lowest limit, so it should be from x equal to y minus 1 to x equal to 1.
Mm, in single integral, why do you always take from 2 to 3, not 3 to 2?
Sir, area can't be negative, na?
Area cannot be negative, but there is nothing about area. It is about the orientation. If I'm in the single integral, you take the integration from 2 to 3. My question is, why not 3 to 2? The value should always go from smaller to larger. Okay, so if you look at the strip, the smaller values of x is on the left hand side, not on the right hand side. Okay, the left hand side end of your strip is on this line, right? On this, the left hand side limit is always smaller for x and right hand side is larger. While giving the limits, you take it from the smaller to the larger. When you have the vertical strip, you take the lower limit first and then the upper limit. Am I clear? And that is the reason why we gave the limits from y minus 1 to x equal to 1.
Yes, sir.
Amol sir. Amol sir. A401. Sorry. Yes, just a minute.